On November 9, the world received two images that no one was ready for. Captured by the James Webb Space Telescope and the Virtual Telescope project, they showed something that shouldn't exist, an interstellar object known as 3I Atlas. At first glance, it looked simple. A single, brilliant of light. But that was the problem. There was no tail. No gas. No dust. Nothing. For an object passing close to the Sun, that's impossible. Comets don't stay clean, they erupt. They shed material. They glow with massive clouds of vapor. But this object? It looked exactly the same as it did months earlier when the Hubble Space Telescope observed it. No change. No loss of mass. No reaction to the Sun at all. And that's where the mystery began. In late October, astronomers noticed something even stranger. As 3I Atlas approached perihelion, its closest point to the Sun, it didn't slow down. It accelerated. That shouldn't happen. According to data from NASA Jet Propulsion Laboratory, the object deviated from its predicted orbit by a measurable margin, enough to translate into tens of thousands of kilometers. Something was pushing it. The acceleration was small but consistent. Precise. Deliberate. And there was no visible cause. Normally, comets accelerate due to outgassing, jets of vapor acting like thrusters. But here's the problem. There were no jets. No glow. No exhaust. It was like watching a rocket move through space, without fuel. To understand just how strange this is, astronomers compared it to a normal comet. Same conditions. Same instruments. One behaved exactly as expected, bright tail, visible gas, streaming material. The other? A perfect, motionless point. Silent. Unchanging. For 3I Atlas to accelerate without ejecting material breaks the fundamental rules of comet physics. Even the most sensitive instruments detected nothing. Zero dust. Zero gas. Zero explanation. When researchers ran the numbers, things got worse. The force required to move an object of this size couldn't be explained by sunlight. Not gravity. Not thermal effects. Nothing we currently understand. Which leaves only one possibility. There's a mechanism we haven't discovered. Or, something we're not recognizing. Then came the next layer of the mystery. Its orbit. 3I Atlas travels almost perfectly along the same flat plane as the planets, the ecliptic. That alignment is incredibly unlikely for an object entering from interstellar space. It's like throwing a dart blindly, and hitting the exact center of a target you can't see. Coincidence? Maybe. But then things got even stranger. At one point, observations suggested activity directed toward the Sun, not away from it. That directly contradicts how comets behave. Solar radiation always pushes material outward. Always. But this object didn't seem to follow that rule. And then there's its color. Instead of the usual white or reddish glow, 3I Atlas appears blue. A deep, high-energy blue. That typically indicates extreme temperatures. But here's the contradiction. There's no corresponding heat signature. No infrared emission. It's producing light, without behaving like something that's hot. That doesn't fit any standard model. Spectroscopic analysis added even more confusion. Instead of a messy mix of ice and rock, the object appears unusually uniform. Its composition hints at metals like nickel and iron, but in proportions that seem organized. Not random. Structured. Even its surface reflectivity is unusually smooth, suggesting something more refined than a natural, fractured body. At this point, some scientists have suggested unconventional explanations. Not because they want to, but because the data leaves gaps. Ideas range from unknown natural physics, to experimental propulsion using solar wind, to something far more speculative, that this could be an artificial object. A probe. It sounds extreme. But the question isn't whether it's alien. The question is whether current physics can explain it. Right now, it can't. As observations continued, one final detail stood out. Timing. During the key observation window, when it should have been easiest to study, the object passed behind the Sun from Earth's perspective. A coincidence, perhaps. But combined with everything else, it adds to the unease. So what is 3I, Atlas? A new kind of comet? An unknown natural phenomenon? Or something entirely different? On December 19, 2025, it makes its closest approach to Earth. Every major telescope will be watching. If it behaves like a comet, we'll finally see the missing gas and debris. But if it doesn't, then we're left with something much bigger than a simple anomaly. Because at that point, the real question won't be, what is it? It will be, how is it possible? Maybe it's just a rock we don't understand yet. Or maybe, it's a reminder that the universe